Hello, welcome back. This is the instruction video for Module 14. Module 14 is going to correspond to Chapter 12 of your OER. We're right in the middle of Unit 4. The focus for this chapter is on correlation. Please remember to be checking in regularly to Canvas so that you can complete your module assignments by the Canvas due dates. You will be completing your video response, your discussion board and peer responses, as well as your quiz on correlation. I wanted to talk about correlation, and I think that many of you have already some experience with the concept because we see it oftentimes used in everyday language, and we also see it in some math courses. The interesting thing about correlation is that correlations can be used as both descriptive statistics as well as inferential statistics. So we can calculate correlation as a description of our data, and the correlation really is examining the relation between two variables. Even though we can calculate this and describe the sample, we can also use correlation as a way to test inferential statistics so that we can predict what a person might score on a second variable given the existing correlation. Correlation might seem a little bit tricky, but really it's just looking at the data from a linear perspective, and in particular understanding how it is that scores on the x-axis change in relation to scores on the y-axis. So really what we're doing in correlation is the basis of what we look at in pre-algebra and algebra in terms of understanding a line, including the slope of a line. And you'll see some of these concepts coming up, although they might look different. They're based on the same ideas. So when we're considering correlation, there are three important things to think about when we look at a correlation. First is the idea of describing the correlation as either positive or negative, and that's indicated by the slope of that line. If we have a positive correlation, this means that the x and y variables both increase together in a positive direction. If we are looking at a negative or inverse correlation, what we're finding is that as one variable increases, the other variable decreases. And then in the situation where we don't see a correlation existing at all, that means that there's no significant relationship that we can predict between the two variables. And that's represented usually as random data with the slope of a line that is equal to 0. So you can think about a horizontal line. Aside from the direction of the correlation, we also need to consider the strength of the correlation. That's going to be the absolute value of what we call R. R is the symbol we use for correlation. R is going to range between plus and minus 1. If you ever are looking at correlational data or try to calculate that, and you get an R that is larger than 1 or less than -1, there's something wrong, because a correlation can only reach 1 if it's a perfect positive correlation, or -1 if it's a perfect inverse or negative relation. Because there's so much noise in our data, we would never expect a correlation to come out perfect in psychology or statistics. So we're typically looking at correlations that are about 0.5 or higher in terms of significance. One important concept that I want to finish with today is that scatter plots are very important when we're looking at correlations. And this is because we need to establish a linear relationship between two variables before we can even explore what a correlation is. Sometimes we'll see a relationship take a different form than a linear relationship. Linear means line. So if we see a curvilinear relationship, a curve, you can think about something maybe that you've seen in the past in math, like a parabola. That's not a linear relationship, so we cannot use a typical correlation to understand that. In psychology, we're going to mostly be using the Pearson R, or correlation, and that's typically used when we can assume normality of the data and a linear relationship. The idea of correlation is really important for us because we have so many interesting studies that we want to conduct in psychology where we cannot manipulate the independent variable. Either it's impossible to do or it's unethical. So correlation can be used as an exploratory tool to reveal a relation between variables, but we don't get any information about causation. And that's a really kind of famous saying in psychology: correlation does not mean causation. And the reason that's the case is that we're not manipulating a variable, we're just observing the relation between two variables. So we cannot talk about variable A causing variable B. All we can talk about is understanding the relation between variable A and variable B. If we found a strong relation and we wanted to try to manipulate that, and we considered it ethical, we could potentially use other statistical tools to set up an experiment where we are manipulating independent variables and we're controlling extraneous or third variables, also known as confounds. Okay, I will see you back in the next video for this course.